Okay, so now we discuss the die temperature relation with surface defect. The temperature of the die is another factor in surface defect. A low die temperature cause cooling of the fluid metal stream, which increase the percentage of solidified metal. Yeah, this is an important thing. As we earlier see the cavity fill time, in which a small variable is called percentage of solid. So if we decrease or we are not able to maintain the die temperature, right? Minimum die temperature. Yes, we will talk about this. What is the minimum die temperature or what is the maximum temperature or die temperature range? But if we are not able to maintain this minimum die temperature range, so we'll increase the percentage of solid, right? So as we increase the percentage of solid, so we are going to increase the filling time, right? For example, if we required 0.03 second, right? 0.03 second filling time. If we increase the percentage of solid, so we are not able to maintain this filling time. We will get some zero point zero 0.04 or zero point zero 0.05. So we'll create or generate this surface defect, right? So how logically die temperature is okay? Yeah, we can imagine die temperature is die temperature is a factor for generating the surface effect. But how? How we can logically understand? Uh, how we can say with the help of some formula? So this is the way. This is the formula in filling time formula. There's some variable or parameter percentage of solid. So as we increase the percentage of solid, oh sorry, we decrease the die temperature, we increase the percentage of solid, which also increase the cavity fill time. Okay, so a low die temperature cause cooling of the fluid metal stream, which increase the percentage of solidified metal in the metal stream. When the percentage of solidified metal is high, the flowing metal becoming stiff and does not knit together, which is also uh, called surface defect, like lamination, as we see earlier in this slides. So when metal streams come together in a die, resulting in wrinkles or lamination or flow lines, right? So many times the effect of cold die can be minimized by filling the die faster by using a higher plunger speed. Yeah, right. See, what happened on many shop floors, we regularly adjusting the plunger speed, some valves, some cycle time or spray time. What we are doing that time, we are compensating our ineffectiveness of maintaining the standard cycle time, or you can say all the we are not able to maintain our all parameter like die temperature, metal temperature, high speed. So and the most common parameter when which we are not able to maintain is a metal temperature. Yes, I would suggest if you maintain your filling time in a close range, you should maintain your metal temperature within plus minus 5 degree centigrade range. What range? Plus minus? Yes, 5 degree centigrade range. Is it not simple as we are reducing casting weight just by reducing our wall thickness? Yes, we have to reduce 100 gram weight because some of the guy also reducing and they are running successfully. How it can run successful without this maintaining these variables? Yes, this is not impossible. I'm not saying this is impossible. Yes, impossible, but you have to take some actions. You have to increase machine tonnage. You have to maintain your parameter in a very close range, right? So mostly on a shop floor, we are not able to maintain this close range. That's why we regularly adjusting this wall high speed or spray time. Yes, because we are compensating another factor. If we are reducing, we are getting low melting temperature, so we can increase fill time by increasing plunger high speed. Please try to understand the combination of this parameter. If you find your supervisor or operator very busy on shop floor, yeah, we don't have time. So they are doing this only. They are compensating every hour. There's some lot of parameter I explain in this. So they are adjusting or compensate every hour. Yeah, sometimes they're reducing high speed, sometimes they are increasing high speed, sometimes they are reducing spray time, sometimes they are increasing spray times. What they are doing? They are compensating the other parameter by for achieving this filling time only. Okay, so many times the effect of cold die can be minimized by filling the die faster by using a high plunger speed. So there are some negative consequences when the fill time is reduced. Yes, but it can often reduce surface defect when the die is cold. The answer is that the plunger can be slowed down for a hot die because the fill time can be longer and they still get the same surface finish. This is valuable to reduce flash at impact. Both the plunger speed and the die temperature need to be measured to take full advantage of these exchanges. Measuring die temperature is necessary for every job, especially on a new die or after major repairs. The die temperature should be measured. Many plants actually measure die temperature several times a shift or every job. It is key process parameter. There are three ways to measure the die temperature: handheld uh, parameter, a thermocouple installed in a die, and an infrared device. So they can mostly shop floor use this infrared device. But yes, I have seen some of the plant or shop floor. They are using there's some thermal camera. I think this is the best way to monitor or measure this die temperature, and you can easily identify if you at a different stages of running. Let's say if you start the die and you take the picture from this thermal camera, so you can easily identify what area is started to hot, and if you run the die 1,000 shot or 5,000 shots, so you can easily identify what area can be are going to be damaged or getting soldering or catching. So this is a very what I think it's a thermal camera is a good device to measure this die temperature instead of this infrared device. And the other thing, hand parameter and the thermocouple installed in die is a very complex activity, and it's a very complex activity to or device to maintain regularly on a die. So they each have advantage and disadvantage. A hand parameter is accurate, but you must stop the machine to use it. A thermocouple in the die give a continuous measurement, but it measure where it is installed only, not really the surface temperature. So you have to use number of this thermocouple in a die. Infrared devices are easy to use, but they are not accurate and can have these errors. Okay, so the timing and the location of temperature measurement are critical, and the measurement must be consistent and done in a specific way if the measurements are to be compared to each other of for process analysis. So this chart show the temperature ranges in uh, degree Fahrenheit, all right, for a good surface finish as compared with an average surface finish. So the temperature was measured with a handheld parameter just after the ejection. Yes, this is an important thing when we have to measure die temperature after ejection of the casting from the die, because we are measuring die temperature to cast a casting, or to know the right e- casting ejection temperature. Yes, yes. So this is the temperature range for aluminum, 475 to 600 Fahrenheit for a good surface finish. For what good surface finish? As you increase your die temperature, so as I told you, you reduce the percentage of solid, right? So you will get the good finish. As you reduce your die temperature, so the surface finish will be average. Yes. Okay. The machine operator is really in a control of the die temperature. It is controlled with die spray. How how machine operator is controlled die temperature? See, with the dye spray, water and oil fluoride. Water and oil fluoride may in a dye. Use some of the people use water to cool down the dye, and some of the people use oil, which is called mold temperature control unit, in which we use hot oil to control or maintain the dye temperature. And the very common parameter is the cycle time of the machine. If the machine is running in semi mode or manual mode, so the operator is God to achieving this die temperature, because they have a time or freedom to do spray for 10 second or 5 second, or taking casting from the die and put on a casting table. So they have own freedom how much time it take in each shot. So 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 this way they can easily maintain the die temperature or control die temperature in the only hand in with this machine operator. The process engineer has designed how the process will operate, and the die design will affect how much difference the changes the operator make will have. But the operator really control how they are used. Very true. So the die temperature is often the primary control for a surface defect, because flash or machine capability limits the plunger speed and the fill time adjustment. Many operators do not understand that they control the die temperature. It is critical that the die temperature, because we should aware that die operator, because uh, many of the machine operator don't know how they maintain, or even they are responsible to maintain the die temperature. We should aware all the operator, you are the prime responsible person on the machine to maintain this die temperature, and how the die temperature is important to get this surface defect, right? Or sorry, to resolve this surface defect. So operator should know he can maintain or control this die temperature. It is critical that the die temperature remain stable, and this means that the everything under the operator's control remain consistent. So this includes cycle time, spray time, and the minimum of short stop. So continuous running is the only goal when the supervisor on shop floor or shift engineer on shop floor. So they should Regularly monitor the machine should running continuously. Okay, so cooling line guidelines. We use water cooling or hot oil cooling in our dye. So there's some cooling line guidelines. So there are some general guidelines concerning water and oil cooling line in the dye. And in the next two slides, we'll discuss these. So first is do not place water lines around the outside edge of the cavity. So these area are already cooled. So we don't need to keep the this water line outside the edge of the cavity. See. So when second one is when designing the dye, give priority to cooling and heating lines even if it is require moving ejector paints or other components. Do not do not use the same line to control temperature in both hot area and the cooler area, right? Because the mostly we'll give throughout the line, so we can give multiple lines, right? Multiple direction of cooling lines, right? What we will face the problem, we face the problem, machining process problem, uh, if we design multiple cooling lines, but it helps to in a long term, right? So depth of cooling line is a critical and must be set carefully. The size of the cooling line must match the desired flow rate. The cooling water should be chemically treated. Cooling water should be chemically treated because deposit of only 0.005 inches reduce the heat transfer by about 40%. Now you can imagine if there's some deposit in your cooling line, so how the heat transfer will happen. They will reduce the 40% of heat transfer, right? All right. It is important to review the physical connection of cooling line to be sure the line are not too large for the connection method. Many times the connection is the restriction in the line that controls the available flow rate. Use constant pressure control, right? And measure the flow and the use flow control, right? At least you can measure manually if you don't have some flow meter or you are not able to purchase this flow meter, so you should measure. You can easily measure the flow of your water. Easily you can put 20-liter bucket and start your this stopwatch and count how much time it take to fill this bucket, 20-liter bucket in inflow, and the same while you can measure outflow, right? So manually it can happen. Use computer thermal analysis to determine the optimum cycle time. Use hot oil to keep the dye hot for heat and stoppage in production. Short stoppage in production means whenever the production is stop, and so you have to um, there's some warm up shot, so it take times or it take some wastage. So if you are using hot oil to keep the dye hot, so it will not take time or this kind of warpage shot wastage. Try to maintain the cooling water and oil temperature at a constant set point. And one more thing I would like to tell you, when you are using water for cooling your dye, so water temperature is not important as compared to the flow rate of water. Flow rate of water, cooling water is more important to maintain your water temperature. Most of the people on shop floor, they believe if we reduce water temperature, dye cooling water temperature will get the good cooling. No, if the people they join this webinar are from all are they from India. There's some place near Haridwar, Rishikesh, right? I'm just giving the example which I feel practically. There's some place, Rishikesh. Whenever you go Rishikesh in summer or peak hot time, so you will find this Ganga river water, they flowing regularly in such a good flow. You will find very, cold water in a very hot environment. The only reason is they flowing continuously in a very good flow. So this is a small from the example which I feel, right, which I have seen, and logically, and in some fluid calculation or heat transfer calculation, you also will find the flow of water is more important uh, as compared to this water temperature to transfer heat. All right. So always keep in mind, don't try to keep this water temperature down. Just keep achieving your water flow. Okay. The cycle time of the process. Yes. Yes, we are going to this complete this webinar. I think we have completed 66. Another 9 or 10 slides are remaining. So keep patience. Yeah, we are. I'm continuously speaking from last 1.5 hours. All right, just 9 slide remains. So let's talk about the cycle time. The cycle time of the process is another important parameter for the die temperature. Yes, the die temperatures at any given time is the direct result of amount of molten metal that went into the die in the last 2 hours. A consistent cycle time is one of the most important factors in a good defect control. The cycle time should be measured and displayed so that the good process control can be achieved. How we can measure or display this cycle time and how it will help to control to achieve good surface defect? See, cycle time study you have to do. For example, if the cycle time is 40 seconds, so all the 10 to I think 12 to 14 activities happen during the die cycle time, like injection, ejection, die closing, die opening, uh, right? So throughout the cycle time, we have to measure each and single activity, how much second it will take, and display this activity is taking this much of time. So another second day, we if we monitor this cycle time, so we can easily find out last day this activity take this much of time. Today, this activity are taking this much of time. So we can easily compare. So this is the way to monitor cycle time. Not only just put 40 seconds. Yes, last day this cycle time was 40 seconds. Okay, now this cycle time is 41 seconds. So how we know? How we know what activity is taking more 1 second? If we had differentiate activity cycle time study, so we can easily find out what activity will taking more time, and we direct control that activities. So this is the way. I have seen many check sheet on shop floor. They easily write down 60 seconds. That's it. How it will help you? How it will help you? Okay, so keep it like this. It is important and the operator control it, but there often is not measurement to tell the operator what cycle time they are running.